There we go. Okay. Good morning, everyone. Thanks for coming. It's bright and early. My name is Michele Titolo, and I'm going to be talking about Cocoapods today. I'm actually going to stand over here, though, because I'm short. So a little bit about me. I'm lead iOS engineer at a small mobile shop called Prolific Interactive. I've been on the Cocoapods core team for about a year now. I also organize with Women Who Code and now Amsterdam here in San Francisco. For those of you that don't know, Cocoapods is the Objective-C library dependency manager. How many people here have heard of Cocoapods, or most importantly, have used Cocoapods? Oh, great, lots of hands. Fantastic. So for those of you that are new, Cocoapods lets you specify dependencies. It lets you specify versions for those dependencies. So if you want to use version 1.2.1 forever and ever and ever, you can do that. And it will also, most importantly, do dependency resolution for you. So you don't have to worry about keeping track of these things manually. You don't have to worry about commit SHAs or submodule tags or all those things that no one really wants to deal with. So this session is about getting your code under control. And with Cocoapods, there's two things that I'm going to talk about today. The first one is private pods. This is a thing. Cocoapods has a mission to encourage engagement in open source. But Cocoapods is a tool, just like anything else, that you can most certainly use internally, and I know a lot of people that do, and a lot of companies that are really succeeding as doing this. So this is kind of the first big thing that I want to talk about. So, a little bit of theory. You can add a pod spec to anything. For those that are new, a pod spec is how you specify a dependency. And it's really this simple. Any repository can have a pod spec. It doesn't need to be specified like in the specs repo. It doesn't need to be separated out and all these fun things. You can just add it. And also any remote can be a pod. So even if you don't have access, if you don't have push access to a repository, you could create your own pod spec and then use that code or use part of that code. So going in a little bit deeper, if you actually want to do this, you can set up your own spec repo. So most of you know of the Cocoapods specs repository on GitHub. It's just a list of pods and all of their pod specs and all of their versions. You can do this internally. I know a lot of companies that do, and it really helps them, have modular code and be able to share code between projects, especially when you're working at a single company and you want the same authentication flow for all of your apps. You want to use the same data storage or any sort of sharing that you want to do. And this is really, really simple. You just follow the format. If you're going to be making your own repository, you just follow the format of the current specs repository. So you have one folder per pod, and then another folder inside, a bunch of folders that just have version numbers. And it will work. And this is the command you run. Pod repo add. Pod repo is a command I know not a lot of people use, but it's actually really powerful and really useful. You add the name of the repository, the URL, and then we suggest going through and linting it, which is checking that it's all set up correctly. If you have any errors, if it can't read from the repository, if there's any problems, this is okay. This does need to be Git right now. We only have support for Git. And of course, this is a myth. People think I want my own private specs repository, so I have to fork the massive one on GitHub that occasionally doesn't render because GitHub can't handle it. Cocoapods specs is the 4th most contributed to repository on GitHub right now. Don't maintain your own fork of that. Trust us, you don't want to do that. So you can have your own independent copy of all of your stuff behind your firewall or your VPN, hosted on your own Git server if you have one of those. And it doesn't ever need to know about the specs repository up on GitHub. They can be entirely separate. The second way, as I mentioned, is you can use any code anywhere. This is the option that I found that I've used most when I've been working with pods internally, because you can add a pod spec to any repository. I have one client right now that has 2 projects, and we're sharing code between them, so I just put a pod spec in the root folder of one repository, and now I'm just using their code. It really is that simple. And in your pod file, you can specify the Git remote with the Git hash rocket. It has to be a .git. It will also, I believe, work with SVN. We also have Mercurial and I think Bazaar support now if you use one of those. But just another caveat, pod specs needs to be in the root folder of the repository. So just like if you were going to be pushing this to the specs repo or your own internal spec repo, CocoaPods will not recursively look through your folders. Make sure it's in the root, and make sure it's named correctly and spelled correctly and capitalized correctly, because sometimes E's and H's get messed up. We all do it. So you can also specify just a pod spec. So if you don't have a pod spec checked in somewhere, if you're, if you want to add a framework or you find something wrong, you can specify a pod spec with the pod spec hash rocket. And this is almost always over HTTPS. There are a couple providers like Bitbucket where you have to worry about them serving HTML to you, but there are ways to work around that. So yes, use this. Have your own pod specs if you really need to, especially if you find something that's not a CocoaPod. You find this more often with like C and C++ libraries. If you're doing something with that, you'll just want to be able to add it, but you don't want to go through the hassle of a pull request, and then they go back and forth, and they're like, we don't want to do CocoaPods. So it's a really easy way to get stuff done. And lastly, you can specify a path. If you've ever made a CocoaPod, this is the most amazing thing ever, because it will actually let you live edit the local code on your machine. So you could have your pod and then be editing your pod in your current project, and it's actually editing the files in the other project. So if you're going through and working on breaking something out into a CocoaPod, this is a really good way to work because someone might have added an import to your PCH and it doesn't compile, but you don't know that until you add it. And this is just specifying a local path. It should be an absolute path, if possible. The pod file really likes absolute paths. You can do relative paths, but absolute works better. So this is all about creating modular code. CocoaPods is a dependency manager, and you can create as many dependencies as you want. But one of the goals when you're using private pods is to really have small dependencies, because you could go and separate your code into 15 different pods, and they can all interlink. But then you start getting where you have one pod that relies on this other pod, and then there's this other thing over there that kind of relies on that second one too. So you want to make things small, and you also want to make them really independent. You want to make sure that if you pull one thing down, it's really just going to be able to work on its own. You're not going to be creating your own internal dependency tree, because you don't want that. Nobody likes saying, oh, there's a bug in this framework that's included by this framework that's included by that framework over there. We don't like dealing with that. We really like flat. That's what I found. So I like to think of this as a great decoupling. Whenever I talk to teams, both at my job and whenever I'm talking with people about CocoaPods, I talk about it as the great decoupling, because it's really making sure that you're going through and making sure that your code is, itself. It is boxed, and you can give it to someone else, and it'll work great. So this usually ends up to something like parts in a machine, where each part is independent, and they're all interdependent in order to make it work. I personally really like this philosophy because it allows you to be more flexible, and it allows you to really extend your code base much faster. Because if you want to spin up a new product, if you want to prototype something, but you already have all of your models in a pod spec, you can say, great, I don't have to worry about the models. I can just pull those in and start working with them right away. So it really helps you be flexible, and it really helps you extend. This also leads to there being more dependencies, and as many people will say, dependencies are bad. When you're working internally, dependencies are kind of a good thing, I like to think, because if you're working on multiple teams, that forces communication, because you're sharing code with someone else, you're sharing knowledge, you're sharing experience. That is always a good thing. Cross-pollination, we love it. But you also have to be careful, because just like with any other piece of software, it can become a mess if you don't be careful and choose wisely. Think that, oh, is this caching layer really something that we're going to share? Do I really need to make sure it's modular? Or is it really just for this one project, and it'll take me 3 extra days to make it modular when I can just say it's done now and then move on to something else if I have a tight deadline? So it's all about being particular about how you modularize your code. And this brings me to the next kind of overarching thing that Cocoapods really helps you with, and that is actually choosing dependencies. A lot of us use third-party code in our apps. It's becoming much more popular. But there is a tendency, especially from doing a lot of Cocoapod support and talking with a lot of people about Cocoapods, they'll immediately say, oh, I need to do this thing, let me just add a pod for it. And then they search for the pod, they add the pod, and that's it. They don't go through the process of inspecting the code that they're really using. Because one of the things that I always talk to people about is you have to be careful about the code you're using, because if you're choosing a library that's not maintained, you're choosing a library that in 2 months is no longer maintained, you're choosing a library that might do something Apple doesn't like, it's now your problem. So you really need to be careful about the kind of code that you are choosing to use. And it is always a choice. We are all great developers, and we know how to build most of this stuff from scratch. Occasionally, there'll be something like, I don't want to implement CouchDB on iOS, so I'll use the pod, that's fine. But there's most of the time, pull to refresh, and the sliding drawer controls, and all of those things are things that we can actually build. But using something that's already out there in the community does help speed up development. So these are just some tips that I tell people when people are like, Cocoapods, your dependencies, everyone's using dependencies, it's terrible code. And I'm like, well, ideally, this is the kind of way that we would like to see people using Cocoapods, and it's about being picky. So these are kind of my criteria that I look for when I'm looking for pods and when my team is. Commits are really important. Most pods are in Git, and most of them are open source. There's a couple ones that ship as frameworks, and there's a couple that ship as binaries. But for the most part, if you can see the code, look at the commits. You want to check out when was the last commit? How frequently is this being updated? How many maintainers are there? Was there a period of 6 months where there was no activity at all in this repository? Those are all really important things to think about, because it's going to help you know how actively this is going to be developed in the future. Because you're shipping this code base, and it's going to be around for a while. It's not like you ship it, and then it just falls off, and then nothing happens for 6 months. You're going to be actively developing this. You need to know that it's going to be worked on, that bugs are going to be fixed, and checking out the commits and the history of the repository is a great place for that. If it's on GitHub, even Bitbucket has this to some extent with watchers. Checking out stars, watchers, and forks. This is not an indication of code quality. In fact, I'd say if something has a very, very high fork number, that might actually be a bad thing, because that means lots of people have had to fix it, or just want to do modifications that don't come back. This, to me, says, if I need help with this, how likely am I going to be able to go to Stack Overflow and find a tag for this? How likely am I going to be able to find a mailing list? How likely am I to be able to say on Twitter, hey, I've never used this before. I have this question, I have this bug. Is there someone out there that knows how to fix this? So this is all about finding ways to get help, because it's not our software. We didn't write it, so we're not expected to know it intimately. So look at this. It's really important. The higher the stars and watchers, usually the better. But then again, you'll find something that was popular 3 years ago. I think at one point there was a fork of ASI on GitHub, and it had so many stars, and I felt so bad, because it's just, no one uses that anymore. But that combined with the commits helps you pick stuff. Looking at open and closed issues, this is something a lot of people don't do, is to actually see how many issues are being filed, how many issues are being closed, and what kind of issues those are. If you actually take a look in the main Cocoapods repository on GitHub, where we actually do gem development, most of the issues that get opened are actually support requests. So it can be a little strange, but figuring out how active is this developed. Are issues actively being filed? Because if no one else is using this, and no one's filing bugs, it could be just really fantastic. You do occasionally find those libraries that are really well made, they're well tested, it's really stable, but we're human, we write bugs, so finding bugs and being able to identify how quickly a bug is going to get fixed is really important. Pull requests. We live in an open source community, and the community contributes mostly by pull requests. So being able to see how old is the oldest one, Is it the same 3 people making pull requests all the time? Is it kind of a mishmash of people? Do the maintainers actually respond to pull requests, or does it just kind of sit open and then like 6 months later it gets merged? These are all indicators on how committed the maintainer is and how you can expect to work with this person or group of people. Because that's really what you're doing. You're engaging with them in a very informal and anonymous way, but you're still engaging with them. You're still using their code. And lastly, and this is something that I really, 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 really wish more people did, is if you're going to be using someone else's code, look at it. Actually go through. Make sure that if it's importing the Objective-C runtime, why is it doing that? You know, Objective-C is so powerful, and there are so many things that could just be really bad that you can do with it. So you want to make sure that you, one, are okay with the way it's handling things. If you see something that has a bunch of IVARs and is not using properties, you should probably think, I should probably find out why they're using properties, not using properties, for example. Or if it's something that's really complicated that you don't quite understand, going through the code and trying to grasp that will help you use the library better. And you'll still, even if you don't understand, like CorePlot, for example, does a lot of really crazy stuff with transforms and CG paths and Bezier paths and all that stuff. You might not have to understand the underlying layer of how core graphics work to understand how the library is put together. What are the different pieces? How do the pieces interact with each other? And how am I going to use that in my code? And this is also really good to make sure that the code actually does what you think it does. Occasionally, if you're doing like the pod search command, and you're just like pod search view blah, 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 it'll just pop up with something, and you'll add it, and you're like, wait a minute, I've used this for a month, it's in here, and it doesn't actually do what I need it to do. So then you have to go back and redo it, or take it out, rip it out, put out something else. So it saves you a lot of time by literally making sure that whatever code you're including that's not yours is up to your standards and you understand it. So in summary, we'd like our code to kind of work like machines. We want Cocoapods enables you to really add any code you want. It is a system for including Objective-C code in projects. That is really at the core what Cocoapods does. And we want to make sure that anyone's able to do that. So there's a lot of tools that just let you do that. And yeah, I hope you all use Cocoapods in private repositories, because it's really been an amazing thing, and I know tons of people that do it. So thanks.
You want to do them in between?
Here, I'll set up one.
Yeah. I mean, I've got a quick one, Michelle. Where do you see Cocoapods going in terms of maybe new features, roadmap, things people are requesting a lot?
Yeah, we've been working towards a roadmap for 1.0. I don't think we've circulated it publicly yet, but there is one.
Can you say things in public, or is it sort of not?
If we have a milestone set up on our GitHub, so that's what we've pretty much been using to track the active issues. There are a couple of refactoring things we want to do, and there are a couple other features like we're working on updating the pod file DSL or pod spec DSL and a few other things to just make it more extendable, maintainable as we move forward. So yeah, it's, most of it actually is in GitHub, but there's some larger things that I know we're talking about that we just, haven't quite figured out how we're going to execute on it yet. So we don't want to say, oh, we're going to do this thing, and then we're like, oh, this requires us to refactor a quarter of our code base. Yeah. So definitely check out, I believe there's a 1.0 milestone on the main Cocoapods gem repository that you can check out and contribute to if you want.
Question for you. A few times now I've had Cocoapods added to the project, and then the underlying project got completely changed and modified and trashed, and then when updated, things fell apart. Any suggestions as to, like the things wouldn't build later on when the underlying things were modified and updated from underlying
Are you talking about the Pods Xcode project or your own Xcode project that is kind of?
I'm sorry. So somebody else's added somebody else's component to the project, and then when gave it to other people, they went in and then they updated. And so how would you handle things like change? What's the recommended best practice to handle when code repos change?
Yeah, so there's a couple things you can do. We always recommend you check in the podfile.lock, which is the file that actually keeps track of all the versions. So if you're ever wondering what version of every pod you've checked out, you can just look at that file. And if you're really worried about sources not becoming available, or for some reason someone pulling a version of a spec from the spec repo, you can check in your pods folder. It's not something that a lot of us do because we like smaller repositories. I'm personally not a big fan of version controlling code that is already version controlled somewhere else. And then you've really big commit diffs, which no one really likes. But if that really does worry you, and I know as Kevin might touch on with some of this server stuff, in order to use Xcode bots, for example, you need to check in your pods folder. So it is an option if you are worried about that kind of change, for sure.
One more question. Sure. I've started moving towards some very small things that I want to share. Usually just a header and a .m, and we might be talking 200 lines of code. The one that I'm just working on is 20. Cocoapod seems to want to build up an entire shared library and everything else. Is there a way to just say, I want these files in?
Yeah, there's a different way to integrate. You can't do it on a per pod level right now. You can't say, have this one pod added to the pods Xcode project, and then this other pod just added to my project. That is not supported right now. But what you can do is integrate all of your pods into your main Xcode project. If you look on the guides website, there's a whole section on the pod file, and I think it's just Xcode proj, and then you specify your project, and it won't create a workspace for you.
Just quickly. But as the provider of the pod, I don't even want to build a whole thing to build a .a. Is that?
You don't have to.
I don't have to. Okay.
No. If you look up the pod spec DSL, there's a thing that says source files, and then you can just say, sources / my file H and M. So, awesome. Thanks.
Thanks, Michelle. Kevin?
Thanks, Evan. Thanks, Michelle. This is working? Okay. So here's the second half of getting your code under control. I'll be talking about getting code coverage working on Xcode and Xcode Server. A little bit about myself. As I said yesterday, I'm the co-founder and engineering lead at AppOrchard. We're an iOS shop based in downtown New York. I worked at Apple previously, as I like to say, at the turn of the century. And most recently, I was the latest author on more iOS 6 development from A-Press. Hopefully no one from A-Press is here. I promise I'm working on the iOS 7 version after I'm done with this presentation. What we're going to talk about today is why code coverage. Just a quick show of hands, is everyone is familiar or unfamiliar with code coverage? Who knows about it? Who does it? Why continuous integration? I'm pretty sure most of the people in this room are well aware of what continuous integration is, and Apple made some noise with the release of Xcode Server, which they call their continuous integration server. But it's not very continuous if you've tried it. Then I'll get into Xcode 5 and getting code coverage working on your desktop, and then we'll transition into how to get it working on Xcode Server. And then I'll talk in a little detail of some of the things I've dug around in the Xcode Server and how it works and where its files are located and things like that. So why code coverage? The goal here is to measure what code gets executed when you run your application. And typically, you run that application through tests, right? The idea here is it's supposed to help you find out what code you actually haven't written tests for, or what code you might need to write more tests for. It's important to note that 100% coverage does not mean you have 100% tests, right? This is just a guide. It's not absolute. As we all know, there are no silver bullets here. And while I was researching this and looking into it, I found this nice quote from Edgar Dijkstra. Testing never proves the absence of faults. It only shows their presence. And I think that's something that we all know very, very well. So what's continuous integration? Continuous integration is really the practice of merging your code often, right? Anyone who's been doing this for a while knows what it's like to go through integration hell when you've gone off on your own or one of your colleagues has gone off and spent 3 weeks working on something and ignoring the rest of the team. At the same time, one way to make sure that your integration's gone smoothly is to do automatic test execution. And this helps you catch problems early on, where it's a lot easier to fix a problem that's only reared its head after 12 hours of development as opposed to 12 days or 12 weeks. So how do we get Xcode 5 and code coverage working? Well, first I want to step back and talk a little bit about what's involved with when you want to turn on code coverage. The first thing is there are 2 coverage files that you need, and these are generated by the compiler and when you run the application. The first is a GCNO file, and that's generated on compilation, and that's an object file, or really a map that tells you what block of code in the object file goes to what lines of code in your source file. Right? And the next is a GCDA file, and that's generated on execution that basically tells you what blocks of code in the object file have been executed. Right? I've looked very hard to find out what these initials stand for. I wasn't able to find it. But they're both part of the gcov, which is part of the GCC compiler collection. It's the coverage tool. So I suspect the GC is part of gcov. I don't know what the rest. Gcov comes with Xcode and is part of the installation. It's nothing to do with the compiler. It's just a specification on how to write those files and read them. And then finally, the last thing I use is something called LCov, which is a nice convenience wrapper around gcov and report generator. You can download it. I'll have the link on a later slide. I just install it through Homebrew, and it works pretty straightforward. So now, how do we get code coverage working in Xcode 5? Right? It should be pretty simple, right? First, you just turn on some build settings, right? Unfortunately, that's not all there is. So we're going to have to do a little fixing, right? And then finally, we need something that will generate these reports for us so they're easy to look at. And so let's go through that. The first thing we have to do is turn on some build settings. And if you go to your application target and look under the Apple LLVM 5.0 code generation, you'll find the first one, which is generate test coverage files. And you just turn it to yes. This is the equivalent of a compiler flag. That's F, test coverage. And that will generate your GCNO files. Right? These get compiled alongside with your object files. Next, you want to turn on the instrument program flow. And this will tell you your application, when it runs, that it should generate the GCDA files. Right? And these also get dumped in the same directory as your object files. And if you do this, it just doesn't work anymore. Right? We used to, in previous versions of Xcode, you just turn these flags on, you run your tests, and you get your coverage files, and then you can use whatever tool you want to look at this, right? And so we have to fix Xcode, right? As I like to say, they used to say, set it and forget it. It just works, and that really doesn't happen anymore, right? The GCDA files don't get generated, and it took a while to dig around, and many people have written about this now. There's a method that needs to get called when your application is done executed. And this is Apple used to do this. It was part of the debug mode. It's no longer done. I don't know why. Maybe now that they have a continuous integration server, they'll turn it back on, but they don't, right? So we have to set this up manually. So this is how we do it after a lot of playing around and making our life easier, because we work on a lot of projects. Is step one, we create a new build configuration. Right? And this is optional, but we just found that it was a lot easier to work with. And you'll see later on when we go to Xserve, use this on Xcode Server, this helps out. So what we do is we just go to the project settings, and we duplicate the debug configuration. Right? This is convenient because it'll make sure that those build setting flags are still turned to yes for our new setting. Right? Step two, we actually go out and create a new scheme. Right? And in this case, you can see on the upper red box, we just call the scheme the project name -demo. And what we do is we change the test action to use our new coverage configuration. Right? Step three, I create a new preprocessor macro for the new build configuration. I just call it coverage, set it to true, and turn it on. And you'll see why this is important. You have to do this for both the application and test targets, right? Don't do it for just one. You'll bang your head, and I have, as to why my coverage files aren't being generated anymore. Step 4, inside our test bundle, we want to create a new custom XC Test Observer class, right? This is a class that runs before your test suite and after your test suite. It monitors everything. And so this is the listing of the file that we have here. As you can see, I've if-def'd it with a macro, right? So that when I build it with any other configuration, this code just compiles down to nothing. Doesn't appear, right? And I've got my implementation. And the first method there is a class method load, right? I chose load over initialize because when you run initialize, if you create a subclass, the initialize method will get called for the subclasses as well. Whereas with load, it only gets called once for the class and all the subclasses. Odds are you're not going to subclass this method, but just be safe. And inside the load method, we set the user defaults for the key XC Test Observer class key to the string XC Test Log, comma, in this case, ren demo test observer, which is our custom observer. XC Test Log is Apple's observer that generates all those test results in your console when you run them. If you get rid of that, you won't see that output anymore. It's kind of inconvenient. Right? And then finally, I create the instance method stop observing. This method gets called when your test suite is done. Right? Fairly straightforward. Call the super, get the application delegate, and then I call the application will resign active on the delegate. And I'll get into that next. So this is how I modify the app delegate to call gcov flush, right? At the top there, I have the external declaration to gcov flush, and in the application resign active, I just call it. It's important to call this in your application and not your test code, right? If you call this in your test code, you're just going to create GCDA files for your test code, and you're going to see the coverage report for your tests. You don't want to see the coverage report for your tests. You want to see the coverage report for your application, right? And that's why you have to go through these hoops of having the test observer call the application delegate, right? You don't have to use application will resign active. It just seemed to be the most convenient point to put it in. You could create your own method if you really wanted to. And then finally, now we want to generate some nice coverage reports, right? And the best way to do that is to use a post action on your test, right? And you created a script, and I'll show the listing in a little bit here. But basically, after the test, you create a new script, post action. You provide the same build settings as the application. That's how you get all the information where everything is. And here's the listing of the script itself. At the top there, right, I'm looking for where the object directory is. There's a lot of caveats about this. If anyone wants to point them out, I'm happy to talk about it. But most importantly, I'm assuming you're running on the simulator, and I'm assuming you're using the i386 architecture here, right? We've gone back and forth on this about running it on multiple devices or multiple simulators versus this one. It just seems like this is the most convenient because we still end up throwing the app in front of users for them to do view testing. So this is how we do most of our testing. I create a path environment variable that is the project source, a subdirectory called coverage. I say there's an info file I want to create inside that directory that will hold all the gcov output from analyzing those files. And then finally, I run lcov basically to capture from the source directory and the object directory and create a coverage file, a coverage report. The next two lines of lcov just simply remove all references to application Xcode inside that coverage report. And that's because you'll get coverage report information on what gets executed in frameworks and things like that. And you really don't care about that because that's Apple's problem, not yours. And then the last lcov line there removes the reference to main.m because that's getting executed no matter what anyway. And finally, the last line there is a HTML generator that's part of the lcov package, and that just generates a nice set of HTML files that show you your reports, and they look a little like this. At the top here is the top level index.html. It gives you an idea of how many lines in your application were actually executed out of the total, the number of functions that were executed out of the total, and gives you a report there. And you can see that this is just building the master detail template straight up. And the coverage is not so great. If you actually click on the application directory, you'll get a breakdown below that, which will either be your directories or files. In this case, it's the files. And you can see the breakdown of how the code is executed within the files. And if you click a file here, you'll see what gets executed and what isn't. And in this case, this is the master view controller. Now, interesting, you'll see that the awake from nib and the view did load methods are marked as executed, even though I didn't write any tests. That's because when you test the application, you're launching the application. This is the main view, the root view controller. And so those two methods are getting executed right away. So again, it's quite possible your coverage report will tell you you're running code and you don't have any tests for it. So you have to know what you've actually written tests for. And this is pretty straightforward. Now, the next thing, we have this in our project. It runs. We can run it on our desktop. We can see a coverage report. So the next thing we wanted to do is get this into Xcode Server and our continuous integration. Xcode Server, how many people have tried using it? How many people are happy using it? Right, so this is Apple's continuous integration server. I kind of try to look at the positives of this. They get it. They understand what we're asking for. I think there are a lot of problems with it. It has tight integration with Xcode 5, where you can set up integration runs from Xcode 5. I don't really use it. I prefer to use the Server.app and the web interface to do most of my stuff. I've just found it's a lot easier. And as I said, and everyone here seems to understand, there are a lot of other issues. I really won't get into them. If you want to talk to me afterwards, I'm happy to tell you what I know with any issues that I've encountered. I know people have had some issues with using GitHub and SSH keys, among other things. So let's go over some of the ideas of how Xcode Server is set up and how it's different than just running straight up Xcode. So at first, we have schemes, right? And as I showed in the Xcode 5 setup, right, I showed how to set up a new scheme to get coverage. In order for them to work on Xcode 5, your schemes have to be shared, right? This is another one that gets people right away, is they don't understand why all of a sudden they've created this new scheme and it's not working on the server or even present. Second is a bot. A bot is basically the configuration to do a build, right? Or an archive or a test or whatever, right? I don't know why they call it bot. They just do. I think it comes from build bot. And then finally is an integration, which represents a execution of a bot, right? A single execution of a bot. And this is what you really care about. So typically, like I said, I create my bots from the web application and not from Xcode 5. And so if you go to your server and you go to the home page and you have nothing else running, or even if you just go to your server/Xcode, you'll see something like this, right? This is a little server I'm running on my laptop, just like great. And it shows you, the latest run. It shows you all the bots you've got, the result of the last run. And up here on the upper right, there are a series of buttons there. And if you click the plus button, that's where you create a new bot, right? And once you ask it to create a new bot, you get presented with something like this, a little pop-up. And it says, step 1, create a new bot. You choose your repository. And as I said before, people have had this. This is why I use the Server.app to set up my repository. I go inside the Xcode, and you can add a repository in there. And it's a lot easier to manipulate and add SSH keys and things like that. You choose the branch you want to build, the location of the Xcode project file or the XC workspace, relative to the project path, the scheme you want to run, and then a name for the bot, right? You go on. You can give it your schedule. You can say build at a certain time, build on commit, or build manually. In this case, I've chosen manually. I've asked it only to perform the test. You can have it run the static analyzer or archive, create an IPA for you. And the other thing I always seem to choose, and some people argue about this, is I want to clean before the integration. I want to pull down the whole repository because I want to make sure that there wasn't some dependency from a prior build that's influencing me going on. The other thing that goes on here is when you choose build on commit, it doesn't use a webhook that GitHub provides you. It pulls GitHub every 5 minutes. So that's another reason why I'm not a big fan of using that one. And as you move on, it will ask you what devices you want to run it on. Right? You can pick it for the Mac. You can pick it for iOS. You can pick actual devices that are plugged into your server. You can pick all the simulators, or you can pick specific devices. And as I said here, I'm just picking the iPhone simulator and the i386 architecture. And finally, you can set up email notifications on success and on failure. Right? So if you create the bot and you've gotten your code coverage going and you run it, I mean, there are a lot of other problems because where are these reports going? But if you dig down, you'll discover the reports aren't being generated. If you actually look at the logs, you'll see that there are a lot of errors when it tries to generate the reports. So what's the problem here? Why isn't this working? Well, I just have to. I can't even. I just have to walk through this. I'm sorry. So when you run Xcode Server, it runs under this user called Team Server, right? That's because it's built on top of the wiki engine, and that was already there, and it runs its own daemon and things like that. And underneath that, there's another daemon called Xcode Build, and that runs under Team Server. And that's the daemon that checks out your project, builds it, runs the post-action scripts and everything else. The problem is when you actually run the test in the application, it runs under user XCS test, right? So you've got everything being checked out and built under one user, but the actual test being executed by another user. So again, what's the problem, right? It's derived data again, right? In Xcode 5, right, on your desktop, all the object files go and derive data under your home directory, right? You do everything as you, right? You check them out, you build them, you test them, you're you. You own all these files. In Xcode Server, they're in some crazy data directory under library server, Xcode, data, bot runs cache, some GUID, derived data, everything else. And they're owned by the user who's checked them out and built them, which is the Team Server user. And you can all guess what the default permissions for that directory is. And so when the XCS test user tries to run its test and write files into that directory, you get a permission problem. So we need to fix code coverage again for the server. So the first thing we do is we add a pre-action on our test. And all we do is just add write permissions to that object directory, right? Unfortunately for us, by using the build settings and using the environment variables, it goes to the right location and looks for that library server Xcode data directory. And we just turn on write permissions for everyone, right? Now we have to adjust the post action to write the coverage data somewhere else. Actually, and I'm sorry I didn't mention this before. You can see here I just checked the user environment variable to see if you're a team server. This way, if you're running it on your laptop or your development box, it just ignores all this and doesn't bother going forward. So here, again, we do the same thing. On our post action, we see if it's user team server. And the first thing we do is we create a temp directory, right? We move all the object files from the object directory to the temp directory. I don't think you should need to do this, but I've seen at sporadic times, which I still don't understand why it seems to work sometimes and not, the gcov and lcov have problem reading the files straight out of the object directory, even though everyone should have read rights to it. So what I do is I create the temp directory, move all the object files to that temp directory, and I change my object path to point to that temp directory for lcov later on. And I create a new coverage path where I want the coverage to go. And in this case, I'm taking advantage of the Xcode Server directory. But at the top level, I create a new directory called coverage. I put the project name, and I put a timestamp on so I can distinguish the builds on this. Otherwise, again, your source directory, where it gets checked out, is, again, somewhere deep inside this bot run cache directory and can get wiped out, especially since I have the clean before every build turned on, and I would lose this information. And again, the rest of the script is the same. Right? So it's pretty straightforward. If you do this and you run it, you'll get coverage reports on Xcode Server. Now, I'll leave it as an exercise to you all to figure out how to get your web server up and running so that you can look at these coverage reports. But it's pretty straightforward. I think we can all do it. So how do I know all this? Right? Well, probably because I spend too much time in the command line looking at all this stuff. But I thought I would share some of the stuff that I found out about Xcode Server, digging around to understand what's going on here. And there are 4 things to look at here. There are the actual server processes. There are the things that are inside the server application bundle. There's the actual server data, or that library server Xcode directory. And then there's a Postgres database that underlies us all. So here are the server processes that show up. So the first thing they do is they bypass all the Apache configuration that's in etc Apache 2, and they create their own. And this is so that they can set up the Git server that runs on Xcode Server and the Xcode Server web application. Right? Next is the Xcode build daemon. This is the daemon that I mentioned that actually checks out the code, builds the code, runs things like this. Interestingly enough, if you dig around, they're not using Xcode build the command line. They seem to have some weird configuration that's obviously undocumented, that they can execute Xcode in headless mode. I'm not sure what the advantages is. Obviously, Xcode build isn't doing everything that Xcode can do, and I'm not surprised they don't tell us. There is a credentials service running here, and that is XCS cred daemon and a cred handler. What they do is for your SSH keys for your repos and for your provisioning profiles, they actually have a private keychain that lives inside the server data directory. And these are the services that access it and feed them back to Xcode Server. And these are the things, if you actually use the Server.app to create a new repository, and you say, I want to use SSH access, and it shows you these SSH keys, and you wonder where they came from, it generates them on the fly. Right? There's a device monitor daemon. This basically detects when you plug in a new device and informs Xcode Server so that you know that you can have this device as an option to build. And then finally, there's this daemon XCS Xcode App Watcher. I honestly don't know what that does. I haven't figured it out. Right? If any of you figure it out, please let me know. I suspect that what it's doing is it's actually watching the execution and detecting when things are done, but I'm actually not sure. Next, we have the server app bundle. This is the server app that lives in the applications directory when you download it from Apple and install it, right? And inside there is a directory called server root, which is very interesting. Underneath it, it has its own system library. And there are 2 directories in there that are interesting. One is the launch daemons. So these are launchd daemons that they get going. And the server setup. These are actually the scripts that run when you run server app for the first time. So you can see what it's doing to your system and what's going on. I dug through this simply so that I can install server on my laptop and run integrations locally. But I don't want server running all the time, so I can turn it off manually without having to delete the app all the time. libexec, which is where the daemons live that are executing. A lot of these are actually scripts, so you can actually read them and see what's going on. And sbin, where some other applications that are mostly used to check the state of the server and make sure things are running well and seeing where it goes. So you can muck around and then see how sbin fixes things. And you can feel pretty confident that you're not going to destroy your machine. Next is the server data directory library server Xcode. again, the data bot runs, these are the individual runs. They're tied by GUID, but it's interesting to look into them and see what's going on. You get more detail that you're not necessarily getting out of the console or the logs. The logs directory, this is not the logs of your builds, this is the logs of the daemons that are running. So you can see, again, why you can't talk to GitHub, because there's a problem with the SSH keys. And repositories, which is where it runs this local Git server and the local Git repositories. And the last thing is this Postgres database. As I said before, this is built on top of the Wiki app that was part of Xcode Server. It's called Collab. Right? You can actually read the database. You have to be logged in as root. But if you put this command in, you can take a look, and if you know SQL, you can be pretty comfortable looking at it. This is a quick slide of the model diagram that's relevant for Xcode Server. There's a lot more in there that you slough through, but this table here on the right is the global entity table. Right? The tables on the left there are the bots, the bot runs, and the associated files with them, so you can actually look to see where files are. This is what it uses to generate that web server page and show you all the integration runs. It has a work schedule, which is how they schedule the jobs instead of using launchd. And there are some weird connections here that I haven't quite figured out, and they seemingly throw NSData blobs in here. The most important thing I got out of looking at this, besides figuring out where everything lives, is they're not using core data. Right? I don't know if that's a good or bad thing. So, but again, you can go crazy trying to figure this out, and so you have to be slightly OCD or have lots of coffee to make this going. And that's it. Here's some information for further information. I recommend that you take a look at the WWDC video on continuous integration. They'll talk a lot more about how to set up some of these bots and get things going and looking at the details of the information. The GCOV page at the Free Software Foundation is not very informative. It actually tells you to read the header file. There's the location for LCOV, but again, like I said, I use Homebrew. There are a lot of things about code coverage and continuous integration, and a good starting point is Martin Fowler's blog right there. And then finally, to understand why you should write tests and about code coverage, there is a nice little coding monk named Testivus who has written a little blog about his thoughts. I'll be putting this up on GitHub, so if anyone's interested, it's, my GitHub username is KYKim, and it'll be under Renaissance 2014. Thank you.